so solving exponential functions or equations, day 1. You ready? It's not, yeah, it's pretty short. Well, but it's algebraic, right? On the next page. Okay, two exponential functions, expressions with the same base are equal if their exponents are equal. This is huge. So this is saying, okay, their exponents are equal if the bases are equal. So do we know what a base is? The b value. The b value is your base. So for example, if I had 2 cubed equals 2 to the x, what can we say about x? Therefore, x equals 3. If the bases are the same, so on both sides you just get it equal to a base to the power, base to the power, the same base, we can set the exponents equal. Okay? So it has to be in this form. It can't be like 2 times 3 squared equals 3 to the x, right? That wouldn't work in that case. We have to just have like 3 squared equals 3 to the x. A base to the power equals a base to the power. An exponential equation can be solved algebraically or graphically. So today we're going to focus on algebraic. That's part 1. Alrighty? Okay, so let's go through this. Seems like a lot of words, but through a highlighter we can highlight. To estimate the solution to an exponential equation, you can enter the exponential equation as a system of equations on your graphing calculator. Okay, so this is day 2. We're going to enter it as a system. So basically what we're going to do is when we have an equation, y1 would be the left side of the equation, y2 would be the right side of the equation. So we'll have 2 equations. What are we going to be solving for then? When we want this side to equal this side, the intersection point. Find intersect. That's what we'll be doing. Yeah. So we'll put in the left side of your equation. I don't know if I got it right. Equation. Okay, so pretty simple. And especially if it's really ugly. Now the downside to the graphing calculator is you have to play with your windows and zooming out and all that stuff. So that's the downside. Well, there's some ways around it a little bit, and I can help you with that. Right, zoom fit, and then you can zoom out from there. Inspire. They have changeable keypads, and so you have to use the one that makes it like a TI-83 anyways, or 84. So really it's the same thing. Yes. Okay. No, once you change the keypad, then it loads the program for the TI-84. It makes it look like a little computer. Determine an exact solution to an exponential equation algebraically. So that's today, day 1. What we're going to do is write both sides of the equation as powers with the same base. Write both sides of the equation as powers with the same base, if possible. If not possible, then at this point we have to use the graphical method. After this unit, we're going to learn logs, and so we're going to learn to solve them with something called logs. And no, it's not like a tree. Sounds like it. But anyways, okay. There's a whole bunch of jokes I'm going to tell. I can't wait. Then set the exponents equal to each other and solve the resulting equation. So basically, once we have base to the power of base to the power of, we can set the exponents equal to each other and solve. Sometimes it's not possible to write both sides of an exponential equation as a power using the same base. In these situations, we're going to use our graphing calculator, okay, for now. So let's look at this example. Okay, so this one says, I'm going to move these for now. For the exponential function shown, estimate the x values when y is 3 and y is 15. Okay, so can you do that? start with y is 3. So y is 3 is here. Approximately -3. Do we agree with that? Okay. So that would be here-ish. So pretty close to, so at y equals 3, x approximately equals 2. That's what that dot means. -3. Okay, at y equals 15. So y equals 15 would be there. What approximately does my x equal to? 6. That was not straight. Okay. So we're going to solve these. And this is where we were practicing yesterday, writing something with the same base. Remember that? I said write it with base 2 or write it with base 3. So you always want to take the larger number and write it and see if you can write it with the base of the smaller. So can I write 64 with base 8? Yeah, 8 to the power of what? 2. This is where knowing your squares and cubes will be helpful, but otherwise you can just use your graphing calculator. Guess and test. Guess and test. I'm going to grab my graphing calculator to open. You might want to have yours handy too. Open. Okay, oops, that's the quiz. Okay, so then what can we say? Therefore, what can we conclude? X equals 2. And then it says verify your answer by substitution. When we do a verification or a check, we always go back to the original. So we're proving left side equals right side. Left side, right side. That's an, I don't know what that is. Right side. So plug in 2. So into the original, 8 squared has to equal 64. What's 8 squared? 64. So that checks out. Okay. All right. Now, this guy has the exponent. So we want to make 1 with a base of 2. How can we make 1 with a base of 2? 0. 2 to the power of 0. We have to remember that. So we went over the exponent laws yesterday. If you were away for that, I have a handout. It's actually in the back. You can grab it. And it has all the exponent laws on there. Okay, so therefore we can say t is 0. And we can do our check. So where do we go to check it? To the original. 2 to the 0 has to equal 1. Does it? You can plug it in if you want. Turn on your calculator helps. Yes, it's 1. So you have to show left side equals right side. Okay, so what do we want to do here? Before we bring it up, which we do want to do that, we want to make 169 with base what? 13. So we start, okay, 13 squared, does it? Yeah. So we're going to write this as 13 to the n equals 1 over 13 squared. We reviewed our exponent laws yesterday. What are we going to do from here? Make it of a negative exponent. So 13n, to bring this guy up, becomes a negative power. Leah, are you okay? Yeah, just tired today. Therefore, so remember yesterday, we talked about if we want to bring this to the numerator, the exponent changes signs. So n equals -2. Let's do our check. 13 to the -2 has to equal 1 over 169. So in your calculator, 13 to the power of -2. And then go math, enter, enter. Okay, can you, oh, we should probably do this one together. Okay, we're going to make it a 3, yeah. Before we do that, there's a few ways we can approach this. We can make it a base of 3 first, or we can get rid of the square root first. What would you like to do? Square root. Okay, So unfortunately with square root, we have to make it in the form of an exponent. So we reviewed this yesterday. If you have, let's make this an n, and this is an m. What does that equal to? Nth root of x to the power of m. M over, and remember it's flower power, the power over the root. So here, what's my power? Is there one? No, so we'd use what number? 1. In a square root, what's the index? 2. It's a 2. Okay, so we have 3 to the x equals, we'll put 27 in brackets. So to what power? Power over root. 1 over 2. Okay, so now we want to make 27 base 3. What is it? 3. So we go to our calculator. Well, what's 3 squared? It's 9. So I try 3 cubed, 27. So keep it in brackets still. So we still have the 1/2. And 27 is going to become 3 cubed. Okay, now what? Multiply. Power to a power. We multiply. So we have 3 to the x equals 3 to the 1.5, or as a fraction. Math, enter, enter. 3 over 2. 3 over 2. Remember with fractions, if you have 3 over 1 times 1 over 2, we go straight across. So 3 over 2. Okay, so therefore, we can now say x is 3 over 2. So our check, we want to prove left side, right side. 3 to the 3 over 2 equals root 27. So we'll just punch it in and get some decimals here. What do we have to be very careful of when you punch in this guy, 3 to the power of 3 over 2? Brackets around 3 over 2, the exponent. So 3 to the power of 3 over 2, and then square root 27. So approximately 5.2, approximately 5.2. Yes, the newer calculators are fancy, and they put it up for you. Yep. For the power, this is it. Right there. Y to the x. Here. Okay. Good to go? So you want to try the next one on your own? Try A and, I don't know. Why don't you try A and C right now? And we'll go over it. Okay, number 1. 10 to the x equals 10 to the 3. So therefore x equals 3. You just show your check. So 10 to the 3 has to be 1,000. 1,000 equals 1,000. Okay, let's go to C. So we first make 16 with base 4, guys. So now we have, to bring it up, becomes 4 to the power of -2. So now, because we have just base to the power equals base to the power, what can we conclude? 3x equals -2. We want to solve for x. Now we divide by 3. So x equals -2/3. So your check should look like 4 to the power of -2/3 has to equal 1 over 16. So in your calculators, what do you have to remember? Brackets. 4 to the power of -2 over 3. Math, enter, enter. Uh-oh. What did I do wrong? Oh, 1 over 16. So we'll just have to go 1 over 16. What? I did answer. Oh, yes, yes, yes. So it's 3 times. Thank you. It's 3 times negative 2 over 3. That's better. 3 times x. Let's try this again. 4 to the power of 3 times negative 2 over 3. There you go, which is 1/16. Ooh, okay, middle guy. We want to make them the same base, so who are we going to change? 81, so we want its base 3. So we start 3 squared, isn't it? 3 cubed, isn't it? 3 to the 4 is it. So we write 3 to the 3x plus 1 equals 3 to the 4. I'm going to show you something that's a very big no-no, but it might help some of you. I'm going to show it to you. What we're doing here is we're writing in a conclusion. So usually we say, okay, because these are equal, therefore we can say these are equal. Does that make sense? So therefore, 3x plus 1 must equal 4 because those two are equal. So doing this is the biggest no-no in the world. We are not crossing off the 3. However, that might kind of help some of you. Luckily, there's no written response in this diploma. If there was, and they saw that on the written, you would dock marks. But you're doing, nope, you're just doing multiple choice numerical response. So if that's helping you understand that, you can get away with it, even though it's a no-no. So all you're supposed to do is go from here to here. So if these are equal, therefore we can say those are equal. Okay? All right. So then what's our next step? X by itself. Spencer, what's next? Take away 1 from 4. Oh, oops, sorry, Steph. I made a mistake. Because it's take away 1. So that gives us 3. X equals 1. Sorry, we added 1. Okay, so check. 3 to the power of 3 times 1 plus 1 has to equal 81. What's 3 times 1 plus 1? 4. So 3 to the 4 is 81. Is it? Oh, painful. No. Okay. So let's look at the challenging questions.
What were those before?
I don't know. Okay, good to go. Next page. Everyone got this down? Okay. Oh, no. Ignore all of this. Okay, good. Select all. No. Okay, just ignore. I have to get rid of it. I'm trying to get rid of it. Just ignore all this. Okay? Just get it. Just ignore. Okay? No big deal. It's not here. It's gone. Okay. But that's gone too. Okay. There you go. So let's solve this algebraically. Because we can do it. Okay, we want to make the same base. Do you want to take a guess what the base is going to be? 5. You're correct. So the first guy is good. Is there a way we can make 1 over 5 with a base of 5? Yes, you can. Well, then that's tomorrow's lesson. Okay, so what can we do? How can we go 1/5 equals 5 to the power of something? What's the exponent on 5? Negative what? So what's the exponent on 5 if you don't see it? 1. So to bring it to the numerator, we're making it a -1. Okay, we're keeping it in brackets. 5 to the -1. Okay, now it's our next step. a power to a power, we multiply. So you could write it, you could still write it like -1 times x plus 2, or you can distribute it right off the bat. Okay, so distributing it, what would it equal to? -x minus 2. So a power to a power, we multiply. Okay, so now finally we have a base to the power of with equals the same base to the power of, so we can therefore conclude 2x equals -x minus 2. Yep. Add x, we want to get x by itself, so let's move this x to this x. Well, we have to combine the x's so we can get x by itself. So I'm going to move this guy to combine them, which is 3x equals -2. Shh. It's on the recording too. Okay, divide by 3. It doesn't say verify, so we don't have to, but if this is a test, I still would verify. So, because then I want to check to see if I got my answer right. Right?
Is there times where if you verify, they make it wrong?
There might be a question where this student checked his work and they show everything and you have to find the error. So those type of situations. But on your like a multiple choice, as long as you type it in right, it should show left equals right, no matter what. Okay. Can you make 27 the same at 9? No. So my question to you is this, guys. Can we use 9 and 27, can they both be written with the same base? Yeah, what would be the base? 3. Okay, so that's good. No, it's... Okay, folks, 3 to the power of what is 9? 3 to the power of 2. Putting a different color to show this replacement of 9. 27 can be written as 3 to the power of 3. Okay, now what? Do you want to try and finish it? No, together. We are a team. Okay. I'm not allowed to be there. I wish. I really do. That'd be a lot more fun for everybody. Okay, so what do we do now for a power to a power? Multiply. You could even write it out if you want to write in this extra step. So we're going to distribute that because we're multiplying with a binomial, we're distributing. So 3 to the power of Jessica. Yeah, what would it be the power of then? Right, you should be writing. 3 to the power of 2 minus 2x. So we are bringing in the 2 here, bring in the 3. 3 to the power of 3x plus 6. So now what can we conclude? Therefore, 2 minus 2x equals 3x plus 6. We want all the x's together. So who do we want to move first? -2, yeah. Make plus 2x. Get out of my way. Not you guys. Just these guys. Okay. So we have, this is gone, 2 equals 5x plus 6 now. Take away the 6. So -4 equals 5x and divide by 5. There's our answer. -4 over 5. Whew, good thing we don't have to check this guy. You did? And okay, can I show you another way you can check, guys? Okay, with your calculator, you can, remember, I showed you this before, but I don't know, it's been a while, and there's so many things you can do on your calculator, so you forget them. We can store an x value, remember? So I can go negative 4 over 5, store as x. Negative 4 over 5, store as x. Okay? And then when you do your check, instead of having to type in negative 4 over 5, especially if it's a fraction that's ugly, I can go 9 to the power of 1 minus x should be equal to 27 to the power of x plus 2. Way easier to check when it's an ugly number. Beautiful. You could just store it as a different number. So I can go 5 store x, and now it's a 5. Okay? All right, so that's it for today's lesson. Grab your, I'm going to show you what your homework is for today. Okay, homework. Oh, maybe it's open down here. See, we are in exponential workbook. So what page are we on for 6.3? 148. Okay, so your homework for the first portion of 6.3. Oops, scared of that. Okay, starts on 143, I think it was, right? 150. Starts at 150. So day 1 runs all of this until, okay, so this is day 2. Actually, no, you can do this today. Yeah, and you don't have to use graphing, right? Because we can go 2 cubed, 2 squared. I want you to practice those. You might need to do them on another piece of paper. All the way up to, okay, so up here. So this is day 2. Starts here. Yeah, 1, 2, 4. Okay, but make sure to show all your work, guys. 1 through 4 for today. Yeah, go ahead. So don't be too long. Sorry. 1 to 4, show all your work. If it says verify, make sure you're showing your check. Stop.